In this video, we are going to solve a compound interest problem. So there are two ways to solve the problem. You can either use compound interest formula or you can use something called as compound interest rate tables. But before I talk about that, let's read the problem. Mr. Ray deposited $200,000 in the Old and Third National Bank. If the bank pays 8% interest, how much will he have in the account at the end of 10 years? So, first thing you will notice is uh, it is not mentioned in the problem statement whether the interest is simple interest or compound interest. So, when it is not mentioned, then by default you are supposed to assume compound interest rate because most of the real life calculations are done based on compound interest rate. So it's a simple, very simple problem. So let's first understand the compound interest formula, and then we can use it to solve this problem. So I have written it here. F, which is future value, is equal to P, the principal amount or present value, times 1 plus I. I indicates the interest rate, which is 8% in our case, to the power n, and n represents the number of years. Now, this formula is interesting. This simple formula only works when interest is compounded on an annual basis. If we have problems where interest is compounded on a monthly basis or on a weekly basis, then formula will slightly modify. If you just do a simple Google search, compound interest rate formula, you will see a modified formula here. Some of the terms, like for example, what we are calling F, in this formula, they are using A, which is final amount or future amount. So, but it's same. Only thing is now it's slightly modified because uh, this formula is will work for uh, all types of compound interest, like whether it is compounded on a monthly basis, weekly basis, and things like that. But for our problem, we can use this simple formula. The compound interest is compounded on an annual basis because they haven't mentioned. So when they don't mention, we by default we assume on an annual basis. So, future value, which we want to calculate, how much will he have in the account at the end of 10 years? So, so that F value is equal to P, which is $200,000 times 1 plus 8% I to the power 10. And if you just want to calculate not the future value, the total amount, but if you just want to calculate how much interest he earned, so what you can do is you can take this formula and subtract the principal amount minus P, which is $200,000 from that, and that will give you the amount, the interest amount, how much interest Mr. Ray has earned. But we want to calculate the total amount, right? So the formula is good. So we can put the numbers here: 200,000, 1 plus 8%, which is 0.08 to the power 10. So let me use calculator here. 200,000 times 1 plus 0.08% to the power 10 for 10 years. So that's gonna give us 400 430 431,784.99. So we can just round it off to 431,785. So F is equal to, let me write it down here. Uh, okay, let's see. We need to format it. uh, text, and it is a normal text. Maybe I just copy paste it. F is equal to, and we got 431,785. 431,785 dollars. That much money Mr. Ray will have in his account after 10 years. And if you subtract 200,000 from that, uh, just to find out how much interest he earned, so he will have earned in 10 years at 8%, 230 to 231,785, right? If we subtract 200,000 from this, so huge interest, because interest rate is high, 8%, and he's compounding it for long period, 10 years. Now, if you don't remember compound interest formula, there is another technique that you can use, and that is very simple technique actually. You can use something called as compound interest rate tables. So let me explain how they work, and then we will use them. So once again, we want to calculate future value f, which is equal to p, which is principal amount, $200,000 in this case, times, we have to multiply that by a factor, f given fee factor. Uh, f give f f we want to calculate given p is given, right? So f given p factor we want to find out from the compound interest rate table, and we want to multiply p with that factor, and the value of that factor depends on interest rate and number of years. Interest rate, so it would be, the general formula would be something like f given p I percent and n. So that's the general formulation, right? P f is equal to p times f given p factor at I percent interest for n number of years. So we can change that I now to 8%, and n is for 10 years. Okay, so let's search compound interest rate tables on Google. So you'll get bunch of links. You can, I will select the first one here. Okay, compound interest rate table. Now the beauty of this using this formulation is, uh, sometimes let's say f is given, you want to find out p, so then p is equal to f times, the factor would change to p given f, right? It can be f given p, p given f, and so it just, you just need to change the factor you want. So the factors goes something like this: what you want to find out, given, slash what is given, right? So as long as you understand that logic, what you want to find out and what is given, you just replace that with that. You first, you put the value that is given here and multiply by whatever that factor is, right? You can make that factor at a certain interest rate and number of years, so you don't have to uh, remember this formula, complicated formula, and many others. Okay, so let's look at the compound interest rate table. So you can see there are different factors already here: f given p, p given f. There are some other things here that I'm not going to discuss right now, uh, but all these values will be given in the compound interest rate tables. So now I'm going to scroll down, and you will see all these different columns represent different factors: f given p, p given f, a given f, and so on and so forth, and their explanation is there, what that means. And this particular table is for 1/4% interest rate, which is 0.25% interest rate. And the first column indicates the n, the number of years. in our case 10 years, right? 10 years. And we want to find out f given p. So that would be the first column. 10 years f given p would be this value. This is the value of the factor. So should I use this value? No, that would be big mistake, because this is 1/4% interest rate. This value is for 1/4% interest rate, and in our case the interest rate is 8%. So we should first look for 8% interest rate table. So I'm just going to scroll down, and 2% and 4%. So keep going until you get 8%. So here is the 8% interest rate. Okay, we want to find out f given p. So that would be and for 10 years, so that is 2.159. 2.159, and that's right here. So 200,000 times this year f given p at 8% at 10 is 2.159 from the table. 2.159. So if you do this multiplication, let me quickly do it. 200,000 times 2.159, you're gonna get 431,800. So you will see that there are some rounding of errors. By using the compound interest formula, you are getting the most accurate answer, which is 431,785. And by using compound interest rate table, you are getting 431,800. So this the difference, when we are talking about hundreds of thousands of dollars, this $15 difference is just a rounding of error between the two methods. Okay, so both answers would be correct. So that's how it works. And in such a simple problem, you might want to use compound interest formula and get the answer. But when things get complicated, like for example, he made first deposit in like first deposit he made in the first year, then suppose he makes another deposit in 3 years from then, and then he takes money out, some money out in the fifth year. So if lot of transactions happen during the 10-year period, then those transactions would be very difficult to put in a simple formula like this. Then we have to use compound interest rate tables. So they are very useful. Now there are financial calculators also available in the market, but I'm not going to discuss that in this video. So I will stop here. Thank you.